A dog's nose isn't just more sensitive than yours. It's operating on an entirely different level of biological technology, one that turns your dog into something closer to a walking chemical analysis lab than a household pet. While you're smelling coffee, your dog is smelling the beans, the water, the heat, and the exact chemical breakdown of everything mixed into that cup, all separately, all at once. Let's break down exactly why, and how much more is actually happening every time your dog's nose twitches. Reason 1. The raw numbers aren't even close. Humans have approximately 6 million scent receptors in our nasal cavity. Dogs have anywhere from 125 million to 300 million, depending on the breed, with scent-focused breeds like bloodhounds sitting at the higher end of that range. This isn't a minor biological upgrade. It's an entirely different scale of sensory input, one that researchers estimate makes a dog's sense of smell somewhere between 10,000 and 100,000 times more sensitive than a human's, depending on the specific scent being measured. To put that in perspective, that actually means something. If a human can detect a teaspoon of sugar dissolved in a cup of coffee, a dog could theoretically detect that same teaspoon of sugar dissolved in 2 Olympic-sized swimming pools. That's not a cute exaggeration. That's the scale researchers actually use when describing canine olfactory sensitivity in comparison to human smell. Reason 2. The brain real estate dedicated to smell is massive. Raw receptor count only tells part of the story. The other half is what happens after the scent data arrives. The portion of a dog's brain dedicated to analyzing smell is proportionally about 40 times larger than the equivalent region in the human brain, even though a dog's overall brain is significantly smaller than ours. Humans dedicate the majority of our brain's processing power to vision. Dogs dedicate a comparable share of theirs to scent. This means a dog isn't just detecting more individual scent molecules, it's running vastly more sophisticated processing on every one of them once they arrive. Where a human brain might register a single blended impression, like the kitchen smells like dinner, a dog's brain is capable of pulling that same air sample apart into its individual components. The protein, the specific spices, the pan, the heat, and even trace scent from whoever last touched the ingredients. Reason 3. Dogs smell in stereo. Here's a detail most people never learn. A dog's nostrils don't function as a single combined intake, the way human nostrils effectively do. Each nostril operates semi-independently, sampling scent from slightly different angles and processing the difference, similar to how your 2 ears let you determine which direction a sound is coming from. This is sometimes called stereo olfaction. This is a major part of how dogs track scent trails so effectively. By comparing the strength of a scent between the left and right nostril, a dog can determine not just that a scent exists, but which direction it's coming from, and, more importantly, which direction it's getting stronger, allowing it to follow a trail with a level of directional precision that a single, combined nostril simply couldn't achieve. Reason 4. The Jacobson's organ is a second, separate smell system. Dogs have an additional scent processing structure that humans essentially lack in any functional form, called the vomeronasal organ, or Jacobson's organ, located in the roof of the mouth, connected to the nasal cavity through a separate duct. This organ is specifically tuned to detect pheromones, chemical signals related to reproduction, territory, and social information that operate almost entirely outside the range of scent humans consciously process. This is why dogs sometimes appear to be tasting the air with their mouths slightly open, a behavior called the Flefman response, pulling scent directly into this secondary organ rather than just the standard nasal passage. It's effectively a second, specialized smell system running in parallel with the primary one, dedicated almost entirely to social and reproductive information other dogs are leaving behind, information a human nose has no comparable way to detect at all. Reason 5. Dogs can smell in layers, not just as a single blend. Human smell tends to work through what researchers call configural processing, meaning we tend to perceive a mixture of scents as one single blended smell rather than picking apart its individual components. If you smell a pot of chili, you smell chili, not the dozen separate ingredients that went into it. Dogs, by contrast, appear to process scent more elementally, capable of distinguishing individual components within a mixture rather than automatically blending them into one unified impression. This is part of why detection dogs can be trained to find one specific target scent, like a particular explosive compound or a specific drug, buried within an environment absolutely saturated with hundreds of other competing smells, from luggage, perfume, food, and body odor. A trained detection dog isn't overwhelmed by that chaos the way a human nose would be. It's mentally sorting through the layers, isolating the one relevant scent thread from everything else happening around it simultaneously. Reason 6. Scent lingers longer for dogs than you'd ever guess. Because of how sensitive their receptors are, dogs can detect scent trails that are hours, sometimes days old, long after a human would perceive absolutely nothing in that same space. This is the basis for search and rescue and cadaver detection work, where trained dogs can locate a scent trail from a person who passed through an area an extended period earlier, based on skin cells and scent compounds that have settled into the ground, vegetation, or surrounding surfaces. This also explains a familiar, slightly less dramatic household behavior. Why your dog seems endlessly interested in sniffing a spot on the sidewalk that looks completely unremarkable to you. To your dog, that spot may contain a detailed scent record of every animal that passed through recently, how long ago each one was there, and potentially details about that animal's health, stress level, or reproductive status, all encoded into a patch of concrete that, to you, looks and smells like absolutely nothing. Reason 7. Scent detection isn't just sensitivity, it's also discrimination. Sensitivity alone doesn't fully explain what makes a dog's nose so remarkable. The other critical factor is discrimination, meaning the ability to tell two very similar scents apart. Studies involving trained detection dogs have shown they're capable of distinguishing between the scent profiles of identical twins, something that pushes right up against the limits of how similar two individual human scent signatures can be. That level of fine discrimination requires both the raw receptor sensitivity and the processing sophistication working together, not one without the other. This combination, extreme sensitivity paired with extremely fine discrimination, is exactly why dogs have become essential in fields ranging from medical detection, including some studies showing dogs can detect certain cancers and blood sugar changes through scent alone, to search and rescue, to airport security. No current artificial sensor technology has managed to fully replicate that same combination of raw sensitivity and nuanced discrimination in a single portable trainable system, which is part of why, despite enormous advances in detection technology, trained dogs remain the gold standard in several critical detection fields. Putting it together, so when your dog's nose is working, buried in the grass, pressed against a stranger's leg, or lifted into the wind on a walk, here's what's actually happening. 125 to 300 million scent receptors gathering raw data at a scale tens of thousands of times beyond human capability, a brain region 40 times larger, proportionally, than the human equivalent. Processing that data with a level of layered sophistication our own brains simply aren't built for. Two independently sampling nostrils working together to triangulate direction. A second, entirely separate scent organ dedicated to social and reproductive information, and a level of fine-grained discrimination precise enough to tell apart scent profiles that are almost biologically identical. This isn't your dog being nosy. It's your dog running one of the most sophisticated biological sensing systems in the animal kingdom. Every single time it lowers its head to the ground, and most of what it's detecting, you will never have any way to perceive at all. Subscribe to Decoding Dogs, because your dog isn't just smelling the world, it's reading it.